Hi everyone, soil mechanics. In this problem, we want to review an interesting problem in terms of factor of safety in retaining structures in soil mechanics. So if we have a concrete retaining wall below the ground in a saturated soil and the harness rod helping the concrete wall. So we want to know how we can deal with the problems, including the retaining structure, saturated soil, harness rod helping the concrete retaining structure against the sliding. So in our problem, the distance between each harness rod is provided to be 3 meters, and we want to calculate the tensile force in each rod. So a long concrete retaining wall stands against a mass of saturated soil below. To achieve the stability, harness rods are embedded in concrete with a 3 meters apart from each other. We want to calculate the tensile force in each rod. If we do know the factor of safety is equal to numeric value of 1, unit weight of concrete is 2.5 tons per meter cubed, and tangent of delta is also provided to be zero point 0.4. So again, we are looking for a tensile force in each harness rod. If the distance is provided. Let's see how we can approach this problem. So again, if distance of each rod is equal to provided to be 3 meters, we want to calculate the tensile force. So factor of safety against sliding is equal to resisting force over destructive force. So factor of safety in problem statements provided to be number 1. That's the factor of safety. Resisting force, we have to calculate that, and destructive force, we have to calculate that, and then make them equal to 1 to get the answer, the only unknown of the problem. So if we just jot down draw a smaller scale of this wall with the soil. So this is the concrete wall. This is the active pressure come from the soil to the concrete retaining wall. So this is the tensile force, and this is friction active pressure force. And there is a friction force which is equal to mu times n, and n is normal force which is equal to weight of the concrete wall, and that's unit weight of concrete times the volume. So for Fa, active force on the soil is a half of Ka times unit weight of soil times h squared, and Ka active pressure coefficient is 1 minus sine of 30 over 1 plus sine of 30, because phi is 30 degrees, and that makes it to 1/3. And Fa, if you consider active force for a distance or width of 3 meters, because each rod are a 3 meters apart from the next one. So Fa is a half of Ka times gamma of soil, which is 2 tons per meter cube, times h, which is 6 squared, the total height, times the width, which is 3 meters. It just gives us a Fa active pressure force is equal to 36 tons. And in the other side, if we want to calculate friction force, that's nothing but mu times n. Mu is nothing but tangent of delta, which is provided to be zero point 0.4. If we replace that there, and friction factor applies to the retaining structure, which is the concrete one, and that's gamma c, which is provided to be 2.5 problem statement, and the volume, which is 6 feet times 6 meters times 1 meters times width, which is 3 meters. So if you do so, it just gives you a friction factors also is equal to 18 tons. And if we have like our a active pressure force like 36 tons, friction force like 80 tons, and the nature of friction, if you can see in the figure, and tensile force in rod, harness rod, they are both in the nature of resisting. They are in a positive x direction. They are not pushing the concrete to the left, but the Fa is just pushing the concrete. So that's the nature of destructive force. So if we have like our F is equal to 1, if you just replace all the resisting forces at the numerator, at the destructive one at the denominator, it just gives us the only unknown to be tensile force in each rod is 18 tons. So again, if the distance of rods are provided and factor of safety is given, the tensile force in each rod is 18 tons. We'll solve another interesting problem in factor of safety against a overturning for the same problem. Keep being with us. Thank you. See you in next video.